We've already seen how to think about something like 64 to the 1/3 power. We saw that this is the exact same thing as taking the cube root of 64. And because we know that 4 times 4 times 4, or 4 to the 3rd power, is equal to 64, if we're looking for the cube root of 64, we're looking for a number that number times that number times that same number is going to be equal to 64. Well, we know that number is 4, so this thing right over here is going to be 4. Now we're going to think of slightly more complex fractional exponents. The one we see here has a 1 in the numerator. Now we're going to see something different. So what I want to do is think about what 64 to the 2/3 power is. And here I'm going to use a property of exponents that we'll study more later on. But this property of exponents is the idea that, let's say with a simple number, if I raise something to the 3rd power, and then I were to raise that to, say, the 4th power, this is going to be the same thing as raising it to the 2 to the 3 times 4 power, or 2 to the 12th power, which you could also write as raising it to the 4th power and then the 3rd power. All this is saying is if I raise something to a power and then raise that whole thing to a power, it's the same thing as multiplying the two exponents. This is the same thing as 2 to the 12th. So we could use that property here to say, well, look, 2/3 is the same thing as 1/3 times 2. So we could go in the other direction. We could say, hey, look, well, this is going to be the same thing as 64 to the 1/3 power, and then that thing squared. Notice, I'm raising something to a power and then raising that to a power. If I were to multiply these two things, I would get 64 to the 2/3 power. Now, why did I do this? Well, we already know what 64 to the 1/3 power is. We just calculated that. That's equal to 4. So we could say that this is equal to, and I'll write in that same yellow color, this is equal to 4 squared. This is equal to 4 squared, which is equal to 16. Which is equal to 16. So 64 to the 2/3 power is equal to 16. The way I think of it, let me find the cube root of 64, which is 4, and then let me square it. And that is going to get me to 16. Now I'll give you an even hairier problem, and I encourage you to try this one on your own before I work through it. So we're going to work with 8 over 27, 8 over 27, and we're going to raise this thing to the negative, and I'll try to color code it, negative 2 over 3 power to the negative 2/3 power. I encourage you to pause this and try this on your own. Well, the first thing I do whenever I see a negative exponent is to say, well, how can I get rid of that negative exponent? And I just remind myself, well, the negative exponent really just says take the reciprocal of this to the positive exponent. So this is going to be equal to, the reciprocal of this is 27. I'm using a different color. Let me use that light mauve color. So this is going to be equal to 27 over 8. Over 8, I just took the reciprocal of this right over here. It's equal to 27 over 8 to the positive 2/3 power. To the positive 2/3 power. So notice, all I did, got rid of the exponent and took the reciprocal of the base right over here. 8 over 27 is the base, negative 2/3 is the exponent. Now, how can we handle this? Well, we've already seen that if I have a numerator to some power over a denominator to some power, and this is another very powerful exponent property, this is going to be the exact same thing. This is going to be the exact same thing as raising 27 to the 2/3 power, to the 2 over 3 power, over 8 to the 2/3 power. 8 to the 2/3 power. This is another very powerful exponent property. Notice, if I have something divided by something and I'm raising the whole thing to a power, I can essentially raise the numerator of that power over the denominator raised to that power. Now let's think about what this is. Well, just like we saw before, this is going to be the same thing. This is going to be the same thing as 27 to the 1/3 power. 27 to the 1/3 power. And then that squared. And then that squared, because 1/3 times 2 is 2/3. So I'm going to raise 27 to the 1/3 power and then square whatever that is. And that is going to be over, all this color coding is making this, just switch a lot of colors. This is going to be over 8 to the 1/3 power. 8 to the 1/3 power to the, and then that's going to be raised to the 2nd power. Same thing we're doing in the denominator. We raise 8 to the 1/3 and then square that. So what's this going to be? Well, 27 to the 1/3 power, 27 to the 1/3 power is the cube root of 27. It's some number. That number times that same number times that same number is going to be equal to 27. Well, it might jump out at you already that 3 to the 3rd is equal to 27, or that 27 to the 1/3 is equal to 3. So the numerator, we're going to end up with 3 squared. And then in the denominator, we are going to end up with, well, what's 8 to the 1/3 power? Well, 2 times 2 times 2 is 8. So this is 8 to the 1/3 is 2. And then we are going to, and then let me do that same orange color. 8 to the 1/3 is 2. And then we're going to square that. So this is going to simplify to 3 squared over 2 squared, which is just going to be equal to 9 over 4. So if you just break it down step by step, it actually is not too daunting.